Hello, class. We're about to start section 4.1 to 4.2 in Math 131. Okay, in section 4.1, it's on pages 399 to 402, and we have problems 1 through 13 odd. So I am going to do problems 1, I believe it's 5, and 7, 9, and 13. Okay, these will be the problems I will cover from 4.1. So let's get started. Problem number 1, it says complete the following table for f of x equals x squared. So now we're given this table of values, which you can see at the bottom of page 399. So we have x, and we have f of x is equal to x squared. So we have -3, -2, -1, 0, 1, 2, and 3. Now, the directions tells us that it's f of x is equal to x squared. That is the function that we're using. So, with f of x equals x squared, we substitute in -3 for x. When we substitute in -3 for x, we get +9. -2 for x, we get +4. -1, 1, 0, 1, 4, and 9. Okay, now these are values that we would get in our table here. Now we go on to, that was A. Now we go to B. It says use the results of part A to sketch a graph y equals x squared. Verify using a graphing calculator. Okay, listen, I'm going to use Desmos. And we know f of x actually means y. And then we could put equals. And then x to the second power. Okay, we have our graph. Now you can sketch this graph yourself on the graph that's shown in your textbook. All right, so now we go here to C. It says, what is the coefficient of the term x squared? Now remember, coefficient just means the number that's multiplied to the variable. So when you see something like this, I'll write this off to the side. Like 5x, 5 is multiplied to x, so the coefficient is 5. That's the coefficient. Now here, x squared, you notice that there's no number in front of x. And remember, when we have a variable with no number showing in front of it, it's assumed to be 1. So the coefficient of x squared is 1. Now we go here to D. It says find the graph, determine the domain and range of the function. From the graph, determine the domain and range of the function. Now, if you look here at this graph, you notice here as this graph gets larger, it encompasses all of the x values. There's no restriction on x. So we could say the domain is all real numbers. That is the domain. Now we look here at the y. We notice that the y values, it includes 0 and all the positive values of y. So with that being said, we could say the range is, there's a couple ways you could write this. You could say the range is all values greater than 0. Well, greater than or equal to 0. Or you could say, you could write as inequality as x is greater than, just to show you what the inequality looks like, you could write x is greater than, no, actually, I'm sorry, it'd be y is greater than or equal to 0. And that's for the range. That's another way of writing it. Okay, now we go here to E. Now with E, it says create a table similar to the one in exercise 1A to show the output for g of x equals negative x squared. Okay. So I have x, and then I have g of x equals negative x squared. Oh yeah, negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, now, well, let me just do it like this here. If we put in negative 3 for x squared, we know that'll be positive 9, but it has a negative sign in front of it. So whatever value we get in here, except for 0, whatever that value is squared, you have to take its opposite, because it's the opposite of the variable squared. So this will be negative 9. This will be negative 4. This will be negative 1. This will be 0. This will be negative 1, negative 4, and also negative 9. So now for f, it says here, sketch the graph of g of x equals negative x squared on the same coordinate axis in part A. Verify using a graphing calculator. Okay, so what we could do, we could go y is equal to, and then we'll type in negative x to the second power. Now what I like about this is it gives us a different color for the line, so we can see that they're basically the same. They're mirror images of each other. So that basically would take care of f. Now we go here to g. G, what is the coefficient of the term negative x squared? Now remember, when we don't see a number in front of the variable, it's assumed to be 1, but this has a negative sign in front of it, so it's negative 1. So our answer here would just be negative 1. That is the coefficient. All right. Now we go here to h. It says, how can the graph of y equals negative x squared be obtained from the graph of y equals x squared? All right. The graph of y equals negative x squared is a mirror image of y equals x squared over the x-axis. Now, we could look right here at the Desmos calculator. If you notice here, these graphs they're mirror images or reflections of each other. Because basically, if you fold this in half, they would lay right on top of each other. So now, we move on to problem number 5. Now, problem number 5 is in the middle of page 401. So we go here to 5a. It says, use your graphing calculator to graph the two functions. Y sub 1 is equal to 3x squared, and y sub 2 is equal to 3x squared plus 2x minus 2. Okay, they want us to graph both of these. So let me do this. Let me turn these graphs off. So you can turn them off by pressing these buttons here. So now I'm going to type in y is equal to 3x squared. Okay, that'll be one graph. And then we will have another graph. It says y is equal to 3x squared. What's that? 3x squared plus 2x. Plus 2x minus 2. Okay. Now, it tells us to graph this, so now we would do 5a. It says, what is the vertical intercept of the graph of each function? Now, we know vertical intercept, just to write this here, vertical intercept is equal to the y-intercept. So the vertical intercept is really your y-intercept. And we know with a y-intercept, x is always 0. So when x is 0, we would take that y value, and that would be our vertical intercept. So to get our vertical intercept, now, here's another thing. It says, what is the vertical intercept of the graph of each function? So remember, the first one is y1. Now, there's another thing here that we need to hit on. Before we go through all of this, there was something in the directions that you all should have taken notice of. And this is the general form of a quadratic equation, which is y equals ax squared plus bx plus c. Now, when you're dealing with the general form of a quadratic equation, the y-intercept or vertical intercept is 0c. So whatever the c value is, that will be your y value, and it'd be 0c for the y-intercept. So if you look here at y1, you notice there is no c. So that c is actually 0. So basically for y sub 1, I shouldn't put equals. I'll put a colon. The y-intercept is 0, 0, or vertical intercept. Now we go to y sub 2. Now we know x is going to be 0, but we look here at y sub 2, its c value is -2. So that is the vertical intercept. Now, just to let you all know this, some of you may be asking, well, how do we know, or why does, when we deal with the quadratic equation, why is c basically your y-intercept? That's because, remember, x is 0. So if you notice here, if we put in 0 for x, that'll get rid of the a and the b. And all you would be left with is c. That's why your y-intercept is 0c. Now, we go here to 5b. It says, compare the two graphs to determine the effect of the linear term 2x and a constant term -2 on the graph of y sub 1 equals 3x squared. So basically, the 2x and the -2 make the graph shift to the left and down. And we can see that here. It shifts to the left and it's down. See if I can make it a little bigger. See how it shifted to the left, and then it's also lower. Now, so that's basically it here. And if you notice here, this is 0, -2, and this is 0, 0 for your y-intercept. So that's basically it for B, for 5A and B. Now the next problem, I believe, was 7. So we look here at number 7, we have g of t is equal to 1/2 t squared plus t. Now they ask us here, we have an answer for A, and we're going to have an answer for B. It says here, it says for exercises 6 through 10, determine whether the parabola opens upward or downward, and then also the vertical intercept. Now we know here with the vertical intercept, y equals ax squared plus bx plus c. And we notice here that the y-intercept would be 0c. Okay, now, that's one thing. The next thing that they had asked us, now that's the vertical intercept, which is b. If you notice here, there is, for number 7, there is no c, or a value without the variable. So we know that this would be 0, 0 for the vertical intercept. Now, to determine if a graph opens upward or downward, we look at the equation. When we look at the equation to determine if the graph opens upward or downward, it's basically determined by the value of A. So basically, it's the value that's connected to the variable squared. So basically, if A is positive, it opens upward. If A is negative, it opens downward. So again, if A is positive, it opens upward. If A is negative, it opens downward. Okay, so here A is 1/2, and it's a positive 1/2. So that means that it opens upward. So that took care of 7A and B. Now we go here to 9. We have R of t is equal to 3t squared plus 10. Now again, A, to determine if it's open upward, we notice that A is positive. So that means it opens upward. And then we come here to B. If you notice here, we actually have the C value. So our vertical intercept is 0, 10. And we're done with problem number 9. Now we come to our final problem for this section, which would be problem 13. So problem 13, it says put the following in order from narrowest to widest. So we had A, which is y is equal to 0.5x squared. We have B, which is y is equal to 8x squared. And we have C, y is equal to a negative 2.3x squared. Now, this is what we would do. We take a look at these values here. We look at the value of our A values. Our A values is what determines which one is the widest and which one is the narrowest. Okay, now, a lot of times we think of widest as the biggest, but we have to think more so in terms of a rubber band. When you stretch a rubber band, it becomes more narrow, but the reaction is much, much faster than it is when it's wider. When you have a narrow graph, that means that it's accelerating at a faster pace than a wider graph is. So what we do is this here. We list our A's. We got 0.5. We have 8, and we have a negative 2.3. Okay, now what we do is this here. We don't look at the signs. We imagine their absolute values. So this is 0.5, this is 8, and this is 2.3. Now, we arrange these from the narrowest to the widest. Okay, so in arranging this, so since they want it from the narrowest to the widest, we know that the narrowest is 8. So 8 would be B. So B would be first, and then second would be C, and then finally A would be last. So this is the narrowest to the widest. So this is basically it from section 4.1. Now we're going to move on to section 4.2. Now section 4.2 is on page 410 through 412. Now with this section here, we're supposed to do problems 1 through 19 odd. So I'm going to pick a few, and then we will go from there. I'm going to do problem number 1, 5, 9, 11, 15, and finally, looks like 19. Okay, these will be the ones that I will complete. So starting with number 1 on page 410, we have, well, actually it's just number 1. We have f of x is equal to x squared minus 3. Now it says here for exercises 1 through 8, Determine the following characteristics of each quadratic function. The direction in which the graph open, that'll be A. And then B is the axis of symmetry. Then C is the turning point or the vertex, determine whether it is a maximum or minimum. And then D is the y-intercept. Okay, so this is what we would do. First of all, we have the x squared minus 3. Now remember, the standard quadratic equation is ax squared plus bx plus c. And then if a is positive, which it is here, that means that it opens upward. Now B, we're asked for the axis of symmetry. Now just to give you a little definition of the axis of symmetry. The axis of symmetry is basically a vertical line that separates the graph into two mirror images, and we're talking about the parabola. So we also have an equation for the axis of symmetry, which would be this: x is equal to negative b over 2a. Now let me clue you in on this here. The vertex, well, just to make this a little bit better here. The x value, the axis of symmetry is actually the x value of your vertex. So basically, if we find the axis of symmetry, we will have the x value, and then once we find the y value, we will have our vertex. And so now, and a vertex is basically the turning point. Basically, if the graph is going upward, the vertex is the point in the middle where the graph stops going down and then it goes up. It's that turning point. And then if it's opening downward, then it's when you go up, it will stop right there at the point that it's about to turn to go down. So now, for B, we was asked for the axis of symmetry. Now we can put it into this equation here. We know that A is 1, but we have no B here. So basically, your axis of symmetry is x is equal to 0. Now just to show it, x is equal to negative, and we substitute in 0 for b, times 2 over 1. So we know this would be 0 over 2, which is just 0. Okay, now, the next thing. We're asked for the vertex, which is the turning point. So if you put in 0 for x here, you know that your y would be negative 3. So our ordered pair here would be 0, negative 3. Now they ask us if this is a maximum or minimum point. Now just to let you know, in the drawing of a graph, of a parabola, whenever your a value is positive and is opening upward, you're dealing with a minimum point when you're talking about the vertex. When your a value is negative, which I'll go here, when your a value is negative, you're talking about a maximum point for the vertex. So here, this would be minimum. Now we come here to D. D says the y-intercept. We know the y-intercept is when x is 0. So it turns out that the vertex and the y-intercept or vertical intercept are the same. It's not always the case, but it just so happened to be in this situation. Okay, now we come to 5. 5 has the same things that we want here. So first, A is positive. So then that means that A is upward. Now we go to B. Now what we want is the axis of symmetry. So we could do that formula. So B here would be positive 3. So it'd be negative 3 over 2 times A is 1. So X would be a negative 3 halves. So basically, x is equal to, you can have a negative 3/2, or you could write a negative 1.5. That's what x is. Okay, now C, we want the vertex, the turning point. So we already have the x value. Let's use the decimal here. So we will have a negative 1.5. And now all we have to do is find the y value. So all we would have to do is put in the negative 1.5 in for x here. And I could just do this here. So we would have, so in parentheses, we had negative 1.5, close the parenthesis, and we'll take that to the second power. And then we would take plus 3 times the parenthesis, negative 1.5, and then plus 4. And that gives us a positive 1.75. So now our vertex is negative 1.5, 1.75. And since this graph is opening upward, that means that this is a minimum point. Now we go here to D. Now D, we want the y-intercept. So we know the y-intercept is when x is 0. So we put in 0 for x, or as you all remember the intercept is 0c. So we know c here is 4, so it'll just be 0, 4. And we're done with problem number 5. Now we go to problem number 9. Problem number 9, it says for exercises 9 through 16, use your graphing calculator to sketch the graphs of the function, then determine each of the following. Okay, A, the coordinates of the x-intercepts for each function, if they exist. The domain and range for each function. The horizontal interval over which each function is increasing. The horizontal interval over which each function is decreasing. Okay, so let's go here to 9A. Oh, well, before we do 9A, let me write the formula. We have g of x is equal to negative x squared plus 7x minus 6. Okay, now A, we want the coordinates of the x-intercept. So let's first type in the equation. Let me turn this off. So we will have y is equal to negative x squared negative x squared, and then plus 7x minus 6. Okay, now we want the x-intercepts. Now the x-intercepts is when y is 0. So it's here at 1, 0, and it's here at 6, 0. So those are x-intercepts. So we have 1, 0, 6, 0. And we know the x-intercept also is when it hits the x-axis. Okay, now B. We want to do the domain and range. Now, if you look here at the domain, there's no restrictions on x. Even though the graph is traveling downward, it's going to encompass all of the x values, which is your domain. So this would be all real numbers. Now your range with your y, you notice here it has a maximum point here of 3.5. So basically, oh, I'm sorry, 6.25. The 3.5 is the x value. So the maximum y value would be 6.25. So basically, the range is g of x, which is your y value, must be less than or equal to 6.25. So now we go here to C. C, it says the horizontal interval over which each function is increasing. Now, if you look here, this function is increasing basically from looking at this graph here, the function increased from here up to when x is 3.5. So basically it's from 3.5 and lower that x is increasing, because remember we read graphs from left to right. So basically the graph is increasing when x is less than 3.5, because once it gets to 3.5, x stops increasing, so it's less than 3.5. Now we go to D. It says the horizontal interval over which each function is decreasing. So basically, if it's increasing when x is less than 3.5, with this here is decreasing when x is greater than 3.5. Because if this 3.5, we know this is 4, 5, and you notice that the values are going down because your y values are going down. Okay, so now that took care of problem number 9. Now we look at problem number 11. Same directions. So we look at A. Well, first, let me turn this off. And we will have y is equal to x to the second power minus 12. Okay, so we got x to the second power minus 12. So now we look at our x-intercept, which is here and here. All right. I don't think it told us how many places to round to, so let's just round to 2 decimal places. So one of them would be a negative 3.46, comma 0. Then the other would be 3.46, comma 0. Those are our x-intercepts. Okay, now B, we're supposed to determine the domain and the range. The domain is basically the same, all real numbers, because there's no restrictions on x. Now the range, if you look here, we have a minimum value here. So basically the range is when y is greater than or equal to negative 12. Because the lowest it goes is negative 12, and then it continues to go up. So basically, we'll put y is greater than or equal to negative 12. It can equal negative 12, but it must be negative 12 or higher. All right, so now we move on to C. Now C again is the horizontal interval over which each function is increasing. Now you notice the function is increasing when we go when x is greater than 0. So we'll put x is greater than 0. Now we want to look at when it decreases. If you notice on this side, coming from this side, we're actually going down. So then x, when x is less than 0, is decreasing. Okay, next problem would be problem 15. We have y equals negative 5x squared plus 6x minus 1. Let me turn off this graph. Let me put this in here. So we have y is equal to negative 5x squared plus 6x minus 1. All right, now we look here at this graph here. So we look at A. We want our x-intercepts, which is here. You have 0.2, comma 0, and you also have 1, 0. That is our x-intercepts. Now we go here to B. We want the domain and also the range. If you notice here, the domain, there's no restrictions on x, so it's all real numbers. And then our range, you notice here, this is the maximum point. So basically, we're going to have values that y must be less than or equal to 0.8. Okay, now we go to C. Okay, C, we want to go over the horizontal interval that the function is increasing. So looking at this from left to right is increasing for values that's less than 0.6. So x must be less than 0.6. And then finally, where it's decreasing, x must be greater than 0.6. All right. Now we come here to our last problem, which is problem 19. And problem 19 is on page 412. So problem 19, it says the average cost to produce pewter oil lamps is given by, let me put this formula down here. So now it says where X represents the number of oil lamps produced, and it says C of X is equal to the average cost of producing X oil lamps. Okay. It says use your graphing calculator to graph the average cost function. And actually, this should be capital C bar of X, not just C of X. Okay, use your graphing calculator to graph the average cost function and determine the coordinates of the turning point. All right, and we know the turning point is actually our vertex. So we're going to use y and x to make this a little simpler. So we have y is equal to 2x squared y equals 2x squared minus 120x plus 2,000. All right. Now we see this graph here. Okay, so now we have our graph here and we want to know what the vertex is. We go here. Now, according to this, it looks like the vertex should be 3,200. So we have A, which is 3,200. 30 for X, 200 for Y. Now, one thing I will like to say is this here. Let's say for some reason you were not able to determine this on the graph. You can use that formula that I gave you to find the axis of symmetry and then come back and solve for y, and then you would get the vertex. So if you look here, B is negative 120 and then A is 2. So this will give you a positive 120 over 4, which is 30. So you see how we got 30 for X, we have 30 for X here. And then all you would need to do is substitute in 30 for X here and then solve, and that will give you 200. Okay, just an alternative way of doing it. Okay, now that's A. Now we go to B. It says determine the vertex algebraically. Okay, so basically we did the first part of it. So we had X is equal to negative B over 2A. Then we'll substitute that in. B is a negative 120. And then we had 2 times 2. So X is equal to 120 over 4, which is 30. So now we would take that equation, C bar of 30 is equal to 2 times 30 squared minus 120 times 30 plus 2,000. Now when you put this in your calculator, C bar of 30 will give you 200. So then we know that the vertex, or the turning point, however they want to list it, is 3,200, which is what we have for A. Now we go here to C. How do your answers in part A and part B compare? They don't compare, they are the same. Well, I guess that's the comparison, they are the same. Okay, D, is the vertex a minimum or maximum point? Now to determine that, we could just look here at our A. Our A is positive, so that lets us know that it's a minimum point. E, what is the practical meaning of the vertex in this situation? Okay, the practical meaning is the average cost of production is minimized when 30 oil lamps are produced. So now we come to F. It says, what is the vertical intercept? Now we know the vertical intercept is the y-intercept. So basically we know it's going to be 0. And if we put that in here, the C value is 2,000. So it'd be 0, 2,000. And it says, what is the practical meaning? Is that it costs $2,000 even when no lamps. I guess I should have put oil lamps. I'll put oil here. Basically, no oil lamps are produced. So it still costs you $2,000 even when you don't even produce an oil lamp. And this is basically it from sections 4.1 to 4.2. If you all have any questions, feel free to email me. Thank you and have a great day.